Hi, and welcome to the final presentation for ParcelPro.
I'm Christopher.
I'm Gadeston.
I'm Madeline.
And I'm Connor. So the primary purpose of our project is to help counties open source the systems that they currently use to manage their parcel information, specifically those related to parcel manipulation, storage, and querying. We're trying to address the following issues in the field. Lack of standardization across county borders, with many counties using different technologies and database schemas to manage their parcels. Ease of use, many existing technologies have a high learning curve, which makes it hard for counties to implement them, and extreme compartmentalization, with sharing data across county borders being extremely different because of said new technologies and different database schemas.
For the overall architecture of our project, we use a Flutter front-end application, which you can see on the left, operating within a user device. Thanks to Flutter's cross-operability, it can actually be a mobile device or a laptop or desktop. Our front-end Flutter application then makes calls to different servers for information. One, you can see the arrow to the Google Maps server, and that's where we get the background map that you see in the interface. And then for parcel data and all other data related to the app, we make calls to our own AWS EC2 server instance. This server is running Node.js Express, which essentially acts as a middleman for our relational database service instance, which runs PostgreSQL and holds parcel data objects along with user data objects. Both of these operate inside of our AWS virtual private cloud to benefit security.
So this is the project walkthrough where you can finally see your project itself. As you can see in the images, you can see some examples of what our project looks like on a desktop. And here we go. We'll show you the actual project. So here is a little screen of the project, and we'll start off by showing the About section. As you can see, the About section has information about editing a parcel, inserting parcel, deleting a parcel, displaying parcel information. Then, of course, when you click a parcel, you can edit it. So you can basically change the lat longs or change how many points it has. For example, since these parcels are squares, if you remove one of the points and then click confirm, you see it turns into a triangle. And you can see the new polygon text. And if we click on edit it again, you can see now it only has 3 points, the 3 original points and the completion point, which is basically just a line drawn back to the start. So basically a repeat of the start. And of course, you can click cancel to cancel and edit. You can also insert parcel, but this is easier to show after we've deleted a parcel. So let's say you have a parcel and you want to delete it. You can either delete it through this button right here, or you can delete it through the delete screen, which will give you some information about the parcel before you actually have to delete it. So here is a delete. And of course, if you have deleted a parcel, but you want to insert it back in, you can, of course, put in the parcel's coordinates. This is a little tedious, but it's important for accuracy to be had in these sort of property boundaries because it's a little inaccurate if you were to make it through clicking. And then click done. And you can see our parcel is back in place. Of course, not with the original information the parcel had. That has to be filled in by somebody manually working through the database. But you can see geometrically, it is the same parcel you originally had. And of course, one of the most important things about this parcel database is its comprehensiveness. As you can see, as we zoom out and go across the city, we have quite a few parcels. And it actually dynamically loads the parcels. So when it loads a new screen in, it only loads in the parcels in that screen, which makes it very efficient because you're only ever loading what's on your display instead of having like other database systems like ArcGIS servers, where ArcGIS servers have to load in basically the entire layer before you can start looking through the individual entries. And that takes very long. It takes oftentimes in some very large parcel data sets with very like small servers, it might take like maybe 15 plus minutes to load in a screen, even if you're just looking at the map for a second. So you might just have to leave the map open, make sure it's responsive. When you zoom out too much, it doesn't display the parcels because that would, of course, overload the computer that you're on. This is a web app, so you don't want to load too many parcels in at once. And of course, one of the most important things is that we have a pretty comprehensive map of Florida. You see, we zoomed into a random part of Florida, and we have the parcels for that random part of Florida. And of course, we have the ownership information and such. So you can just go to a random part in Orlando and see this is a mixed use storage office or blah, blah, blah. You see the owner name, you can see where the owner lives, you can see the physical address, and you can see the actual geometric information about the parcel itself. Basically, these are the long lat pairs, and you can reconstruct the parcel using this information. Basically, any other app, you can just copy paste it and export it to somewhere else. And this is quite useful for anybody who just quickly wants to know exactly where their property boundaries are, exactly where it's like marked. And it's quite useful in that sense, of course, because it gives you a pretty comprehensive view of parcels. And as you can see, as it zooms out, it clears out the parcel screen, which makes it quite efficient to use. And this is why it makes it quite efficient to use across county boundaries, because there's just one standardized table for all the counties. And that is sort of the intended way of using it. If you were to basically export our own tool, we would want you to use it in such a way that you basically add to the table in the format that the table is already in, and basically just make your data fit the table. And as such, the map would expand. But of course, we allow you to use the table any way you quite want. And of course, to show you that, of course, the delete here still works, this button that we haven't shown off, you can see, deletes the parcel. And of course, let me see if I can find one with the hole. But yeah, that's about it. We have full functionality of edit, delete, insert, looking at the parcel information itself, modifying basically the parcel geometry. And that's the important part, that you can use this tool basically in any database. You can use the same functionality, and it basically provides a very easy way to interact with the geometric aspects of a database. So again, if you want to know who owns a random part of an island on the Venetian Islands, you can see right here, it's owned by Mustafa Aktas. And that's just the primary functionality. Quite easy to use, quite elegant, and nice and easy to implement if you want to use it yourself. That's about it for the actual demo.
As for my individual responsibilities, I was chiefly in charge of the database where all of our parcel information was stored. And so on top of developing API endpoint functionality, which basically allowed the Node.js Express server to communicate with the data and manipulate it as necessary, I also implemented data security measures and did a lot of different manipulations to our data for query optimization. And so on the right, you can actually see a script I used to manipulate our table data that significantly reduced the query time so that it was actually 80% faster on every swipe of the map to bring up those green parcel shapes you see. I did this by basically shrink wrapping the parcel shapes so that certain points that were redundant effectively got deleted. So that way, when it draws it on the front end, it's much faster, as well as being less data to transmit from the back end to the front end. Also, I did some query structuring so that the parcel info would only have relevant information, and then some database indexing and automatic ID updating so that whenever data was retrieved or added, it was done in a way so that data integrity was maintained.
So as the project manager, I performed these following functions myself. I organized meetings, guided scope, did a bunch of interviews myself to make sure that what we were working on would be practical and useful in a specific use case. I worked on both sides, front end and back end, laying out the groundwork for the API. That was my primary thing that I worked on. And on the EC2 instance, making sure it's accessible from the app, making the parcels display in the app and be drawn out properly, helping with control flow, making sure that the new features and new updates being made didn't break anything, making sure to check up on each commit and stuff to make sure everything works. Of course, working on the parcel related issues and making sure that they're editable, deletable, creatable, making functional and useful government applications. So basically, I'm the one that implemented the primary API functionality in there, where the insert, edit, and delete are all properly working with the UI modifications and no issues are found. Of course, you get the full functionality of CRUD, basically create, use, create, read, update, delete, where basically you can use the database geometrically any way you like in a very simple format without having to know anything about the SQL or geometry or anything about that in the database itself.
So, me and Connor mostly focused on the front end. For my individual responsibilities, I did research and implementation of the Google Maps API, and then I also set up the map screen and the foundation for the front end development. And then I also implemented the left sidebar menu, which initially used a package called Collapsible Sidebar that we eventually decided to switch to building our own collapsible sidebar from scratch because of a few bugs.
And I worked on the initial Figma UI design that we had, as well as integrating parcel data into the front end menus and adding the callback functionality to the widgets.
Yeah, overall, me and Connor worked pretty closely together on creating the front end, and we did most of it together. So we did a lot of research for Flutter and how to create a web app in Flutter with the specific requirements that we needed to create this type of a app. And then also integrating widget libraries and mainly working on the UI and front end functionality with the map screen, the left sidebar menu, and then the various right sidebar menus, which are edit, insert, delete, and info, and then also integrating the functionality that Chris is working on in the back end with these different menus. Thank you for watching our presentation and helping us do this project in this class.